Hello, so this is another question I prepared for my interview. It's basically a linked list question, and we're using a singly linked list, which is one node after one node after one node, and each node contains its data itself and also a pointer to the next node. So the advantage of this is if you want to add or remove a new node, it'll be very fast, because the operation is just to change the pointer. If you add a node in the middle, we're basically looking for the next of the previous node and pointing to the new node, and also change the next of our new node into the next node. This will be the adding function. And to remove it, we're basically looking for the node we want to remove and change the next of the previous one and pointing to current next. So this node will be discarded, and it is very fast. But the disadvantage is if you want to find a node in the middle, this will be slower, because the operation will looking for from the head node one by one until it finds this node and then return this node. So here is an example question we can use to understand this better. So for a linked list containing the below node A1, A2, A3, B1, B2, B3 until Bn, we want to rearrange everything into this order: A1, B1, A2, B2 until An, Bn. So to approach this question, it's easier to just take this example out onto a paper. And if we want to do this one, and we know the node is going from the beginning to the next. So if we want to rearrange this in the other order, we basically want to take the one from the middle and joining the first one. And since at the beginning it only starts from the header, which means the easiest way I can think of is we create two pointers. So for example, we can say one pointer can give a name called walk because it's slower, and we can do another pointer called run, which is faster. So the walk will go like this: header and one by one, and the run will be faster, which will start with the header 2, but instead we run 2 steps each time, because here we don't know the size about this array, about this list, but the only thing we know is because it's A1, B1, so the item we want to arrange has multiple of 2, because A1, B1 it's a pair, so it's it's multiple of 2. That's why we have a walk which runs every 2 steps, and the walk runs every 1 step. Sorry, my bad. And the run is faster, runs every 2 steps. So the algorithm will take the walk and one by one, and also when it runs jumping fast. It runs faster than the walk. So when the run reached the end, and the walk should be only in the middle, either the last in the middle, the one before the middle, or the one after the middle. So in this case, we will know exactly where the middle item is, and then we can take the run pointer back to the front. So now we actually can just print out the node from the middle, joining by the node from the beginning, and then it will be B1 A1 or A1 B1. So that's our game plan, to join it together.